Have you ever spent an hour or more waiting to be checked in at an airport? Pioka International Airport suffers from a heavy amount of passenger traffic during peak traveling times throughout the year. They are slowly implementing ways to overcome this traffic, but more needs to be done in terms of the bag drop process. Measures have been implemented geared towards relieving congestion, such as web check-ins as well as self-check-in kiosks. However, nothing has been done to alleviate the bag drop process. There are two main processes that must be undertaken prior to the passenger boarding the plane after booking their ticket: check-in and bag drop. The check-in process consists of the passenger providing a form of ID to receive a seat for the flight they booked. The bag drop process consists of generating a bag tag, then weighing the luggage, attaching the bag tag to it, and finally putting the luggage on a conveyor belt to be transported to the baggage area. Currently, Caribbean Airlines, particularly at Piarco, carry out these processes manually. This means that passengers will wait in a check-in queue prior to them being attended to at the counter, and this is where a member of staff will check in the passenger and perform the manual bag drop process. The solution proposed is a self-service bag drop embedded control system. The aim is to eliminate the manual process through the implementation of an automated system. The new system will allow passengers to scan a barcode printed on their boarding pass to generate their own unique bag tag that they will attach to their luggage. The luggage is then weighed and scanned to ensure that the bag isn't breaching any weight or security restrictions. Provided that the luggage does not violate any of the checks, the passenger will be notified by a green light and confirmation slip that their luggage has passed, and the bag is then pushed onto a conveyor belt that takes the luggage to the back-of-house area to be loaded onto the plane. However, if the luggage fails a check, the passenger will be notified by a red light, and the user screen will display a seek assistance message along with directions to a holding room where the passenger must go to resolve the luggage issue. The passenger can then repeat the weighing and scanning process from within the holding room. The seek assistance function allows passengers to rectify their luggage issues. Overweight luggage can be rectified by the passenger paying a fee for his excess luggage or removing items until he is within the regulatory weight range. Security issues are rectified by removing illegal items from the luggage. Functional requirements include scanning a boarding pass, printing a bag tag, determining if the luggage weight is within regulatory range and free from any security breaches, and transporting the luggage to the back-of-house area or holding room based on its weight and security screening. Non-functional requirements include informing the passenger of the airline's policy regarding the amount of luggage allowed and the weight restriction, informing the passenger if they have exceeded their limits, and having a customer service rep. The design pattern used is the Model View Controller pattern. The self-service bag drop system allows users to interact with it in different ways. Listed are the ways in which the pattern relates to the system. The passenger interacts with the system's monitor to initialize the process. Firstly, the passenger scans their boarding pass, and then the system will prompt the passenger to load their luggage onto the scale, after which the system will display the luggage status and luggage count. If the luggage is in breach of the weight or security restrictions, an error message is displayed and the luggage is sent to the holding room via the conveyor belt. The passenger will then make their way to the holding room where the seek assistance personnel will deal with the situation accordingly. If, however, the luggage does not breach any restrictions, the passenger's unique bag tag is printed with the passenger's name and bag tag ID on it, with an accompanying receipt. The passenger then attaches their bag tag to their luggage.
Test cases that were taken into consideration: processing a valid boarding pass, processing an invalid boarding pass, equipment being unable to read data from the boarding pass, processing luggage that does not breach restrictions, processing luggage that breaches restrictions, printing a bag tag correctly, not printing a bag tag correctly, and transporting luggage to the holding area. This project is susceptible to various risks. These risks can be categorized under the headings technological, organizational, personnel, requirements, and estimation. Technological risks range from hardware unavailability to power failure. One of the most significant risks, however, is the risk of the internet breaking down, as this has a moderate probability and can prove to be very catastrophic to the system and by extension the airport's business. One strategy that is put in place to deal with this risk is in the form of a contingency plan, which is having an alternate internet service provider so that if one experiences difficulty, the system can still be up and running. A significant organizational risk to be considered is having a lack of top management commitment to the project. This risk also has a moderate probability and can seriously affect the project. One strategy put in place to handle this risk is to minimize the opening for the staff fund by pausing the project's development until there is a fully committed manager available. Personnel risks range from having group members falling ill to a lack of motivation in the production team, or having team members with negative attitudes towards the project. One of the more significant risks, however, is stakeholders having inaccurate expectations for the project. This risk has a moderate probability but can seriously affect the project as well as the final product. The best strategy for handling this risk is ensuring that there is communication between stakeholders and the project team to clarify any misconceptions. Requirement risks range from gold plating and scope creep to omitting requirement activities in the scope definition. However, the most significant risk is running into unforeseen design, implementation, and testing difficulty as a result of faulty requirements for interfacing the system with other systems that are not under the team's control. This risk has a high probability and can affect both the product and the project. However, this risk is tolerable as it can be handled by the team researching existing systems and gaining an idea of how the interactions will occur to come up with a design to reduce the risk. Estimation risks consist of the estimation time for the completion of the project development being affected by changes in requirements. This risk has a very high probability and can affect both the project and the product. However, it is tolerable and can be minimized by hiring someone who specializes in the area of the incomplete task to handle it. The cost modeling technique used was estimation by analogy. This method involves using an analogous or comparable system or subsystem in a similar application domain to estimate the cost of the proposed system based on historical data. This cost model technique was chosen since there is a vast amount of project data available which will assist in relaying an accurate price. The total project cost was estimated to be $3,382,453 US. This chart shows how the sum of money was allocated amongst project management, hardware, software, testing, training, and reserves. Project management accounted for the largest portion of the total cost at 60%. The next highest being software costs, which accounted for 11%. Included in this software cost was the price of developing new software, which was calculated using the constructive cost model, or COCOMO. This screenshot shows the COCOMO website interface with relevant project characteristics inputted and a resulting estimated cost to develop the software.
Created using Powtoon.